All right, we're going to be working in Chapter 7, and we're going to be working Lesson 1. And what we're going to do is we're going to start talking about exponents in this chapter, okay? So what I want you to do right now is I want you to pause the video, and I want you to try to answer 1 to 4 on your own, okay? So go ahead and take a second, pause, and try 1 to 4 on your own. Okay. So on the first one here, we're going to look at 3 to the 4th. And keep in mind, 3 to the 4th is 3 times 3 times 3 times 3. Okay? So 3 times 3 is 9. And we get 9 here. And then 9 times 9 is 81. So your answer for 3 to the 4th is 81. All right, number 2. All right, so this is in parentheses and it says negative 2 to the 3rd. So it's saying take negative 2 times negative 2 times negative 2. All right, so negative 2 times negative 2 is 4, and then multiply by the next negative 2, or that third one there, and you're going to get negative 8. All right, third review problem here. 2 to the 5th. Now, it's been a little while since we've seen this, but just keep in mind that we are dropping the 2 in kind of to both parts. Or if you want to think of it as 2/5 times 2/5. So 2 times 2 is 4. 5 times 5 is 25. And 4/25 is your solution. All right, so now on number 4. I went ahead and kind of started this early. We're going to actually talk about it again here a little bit later. But is negative 5 squared the same thing as parentheses around negative 5 squared? And your answer should have been no. All right? So when I'm looking at this first guy here, this is saying square the 5 only. If it is not in parentheses, you're not multiplying negative 5 times negative 5 like this one says. You're actually going to, I can take that off. You're actually just going to square the 5 and get 25, and then you're going to drop down your negative. So your answer here is negative 25. That will not equal this guy, which is saying take negative 5 times negative 5, which is positive 25. Okay, so there is a huge difference between when we have parentheses, it means go ahead and multiply that number twice, versus when we don't, which is just saying square that base, square that 5. So 5 squared is 25, and then drop in that negative. Okay, and again, we'll look at that here again in just a second. All right, so we have a couple really important rules. Okay, first off, the 0 exponent. Anything raised to the 0 power is equal to 1. That's it. Super easy there, but it's equal to 1. So if I look at example here, 4 to the 0, guess what? It's equal to 1. It doesn't even matter if it's in parentheses to the negative 3. It's still 1 because it's to the 0 power. And again, it won't even matter if we have an exponent. Anything to the 0 power is 1. So all 3 of those are going to be 1. And now let's think about this, because my guess is a couple of you probably were thinking, no, why isn't it 0? Okay, because that's probably what I would have thought too. It's not possible for, think about 0 to the 0 power. So we said anything to the 0 power is equal to 1. And then we're saying, but what about 0 to the 0? So if you try to plug in 0 to the 0 into your calculator, so if you do that right now, you're actually going to end up with a math error because you have nothing to the nothing power. So in this case, when you have 0 to the 0 power, you're going to get undefined. Okay, so pretty much everything except for this one special guy right here is equal to 1. All right. All right, and then we have a negative exponent. So when we reviewed up here at the top, so if you kind of look back up here, we were just talking positive exponents and what to do. So now we're going to take a look at something like what do we have when we have 7 to the negative 3rd. So when we have a negative exponent here, the negative exponent means that we are going to drop this down. It really means fraction. So when you see a negative exponent, you need to be thinking fraction, okay? So I'm going to drop a to the n on the bottom. Notice how my negative n became a positive n. So when you change sides, you change the sign, okay? And then since I don't have anything left up on top, we're always going to put a 1 up there. So it's really a fraction. So anytime you've got a to the n, okay, again, negative n, it's actually just saying it's a fraction, okay? So let's take a look at this one. So example, 7 to the negative 3. So it means that we're going to drop this guy down to the bottom and get 1 over 7 to the 3rd. Now, I would expect you to be able to take 7 times 7 times 7 and come up with that would be 1 over 343. Okay, look at the next one. So again, this is the same thing. This negative exponent is telling us we've got to drop the whole thing to the bottom. So I now have -5, so keep the base the same, -5 squared, and then put a 1 on top. So now, again, we just talked about this, but if I have a -5 squared, it's actually saying -5 times -5, so just keep that in mind. It's saying -5 times -5, which is a positive 25. So 1 over 25. And it won't matter even if we do a variable, okay? The variable means just drop it down. So you're going to get w to the 4th. Again, notice how the exponent goes from a negative to a positive, so it changes signs, right? Changes signs when it changes the side of the fraction. And we're going to be left with a 1 up on top. All right, so next part here. All right, so this says 0 can never be a base to a negative exponent. The result will be undefined. All right, so let's think about this for a second. So if I have like 0 to the -3 power, all right, you guys would say, well, that negative means it drops, and so we get 1 over 0 to the 3rd. Okay, we have talked about this before this year. You cannot have 0 in denominator. This is no good. It can't happen. Go ahead and try to put 1 divided by 0 in your calculator, and you get undefined or math error or something like that. So you can't have 0 on the bottom. So this does not work. Okay, so your answer would be undefined if you get something with a negative exponent and a base of 0. All right, so now again, this is the same thing. We just talked about this a little bit ago. Having a negative inside parentheses is not the same thing as having a negative without parentheses, okay? So when we're looking at this, just keep in mind that this guy would say -2, this whole thing drops, so I get 1 over -x squared, all right, versus this guy, which says only the x is going to drop, okay? And maybe even back here, I should have maybe circled the whole thing. This whole thing is going to drop. Where here, all that's going to drop is that x. It's going to become x squared, right? We move to the bottom, we change the sign. But then this -1 is still hanging out at top. So those are not going to be the same thing, because if I look at this guy right here, a negative times a negative will be a positive. So this guy will give me 1 over a positive x squared. So these cannot be equal, okay? Again, so if you're looking at something like this, you would have this negative, the whole thing would drop. So you'd have 1 over -6 squared, which would be the same thing as 1 over 36. -6 times -6 is 36. Where on this guy, only this guy will drop. So you have -1 on top and 6 squared on the bottom. So you end up with -1 over 36. Again, they're not the same thing. All right, so now I want you to go ahead and pause the video, and I want you to try example 1 here. I want you to try A, B, and C on your own, and then push play again. All right, so you should have tried this one on your own. So 4 to the -3, right? Negative means it drops. So you end up with 4 to the 3rd on the bottom. Again, when it changes sides, it changes signs, and a 1 on top. And then you should have taken 4 times 4 times 4 and ended up with 1 over 64 as your answer here. Okay, going to the next one. Anything to 0 power equals 1. And on C, all right. So again, it's in parentheses. So this whole thing's going to drop. So you're going to get 1 over -5 squared. Okay, so notice the base is not changing, right? The only thing that's changing is that exponent. So then you end up with 1 over 25. Negative times a negative is a positive. All right, go ahead and flip over. All right, so now I want you to go ahead and write down what you think the answer will be for, let's go ahead and do D and E. And just write down, so pause the video and try those two and see what you end up with. Okay, so you should have on D here, okay, negative 1, or negative 9 means drop it. So you're going to get 1 over x to the positive 9. So when it changes sides, that exponent changes signs. Okay, next one. All right, so now this one was a little trickier. So if it has a positive exponent, so like 5 to the first, that there's always an exponent of 1, even if we don't write it, and a to the third. Well, these two are positive, so they don't move. The only thing that's going to move should have been that b. So you're going to have 5a to the third on top, and b squared moving to the bottom. So this guy has to drop, but since these two are positive, we leave them alone. Now, I can't clean up anything, I can't do anything here, so this right here is your final answer. All right, let's try the next one here. So now we've got a negative, but it's on the bottom. So to get it to be positive, because you always have to have a positive exponent, we're just going to move it up. So I'm going to take c to the negative 3 and bring it up and get c to the positive 3. So again, when you change sides, it just changes your sign of your exponent. Now, if you want to put a 1 out front, you can. You don't need to do that, though. So this would be your answer. Okay, I want you to go ahead and pause the video now and try G and H on your own. Okay, so on G, negative exponent, right? This guy should have moved up, so you'd had 2a to the third. Nothing else can be done there. That's your final answer. Okay, next one here. All right, so this doesn't move because he's already positive, so m squared is going to stay on the bottom. Now this guy has to change. Anytime we have a negative exponent, you have to move sides. So n to the fourth comes to the bottom. There's nothing left on top, so I put a 1. Now, this is not important, the order. If you've got these two flip-flopped and you put something like n to the fourth, m squared, that would be fine as well. I would take either answer there. So here would be your solution. All right, so now in example 2, what they're asking you to do is they're actually asking you to find values. So you're actually going to plug in these numbers right here, negative 2 and 5, and you're actually going to come up with answers, okay? All right, so let's kind of zoom in here. Whoops. And we're just going to plug in. So n was negative 2, so I have negative 2 to the negative 4, and 5 to the 0, okay? All right, so now anytime you've got something to the 0 power, right here, that's always going to go to 1. If it goes to 1, it's not going to change the value of anything, so you don't even have to worry about it, okay? So what I'm worried about really is just this first guy, and since it's a negative exponent, right, we're going to drop it. So we're going to have 1 over negative 2 to the fourth, and then you're going to have to figure out, okay, negative 2 times negative 2 is 4. 4 times 4 would be 16. Okay. All right, let's try the next one here. So we're going to do, I got the numbers. Okay, negative 2 to the negative 1 over 5 squared. Okay. So now again, I have a negative exponent right here, so that means this entire top part is going to drop down. So I'm going to have a 1 on top because there's nothing on top. I have negative 2 to the positive 1 now, and then that's kind of like saying 5 squared. So if I think about that, negative 2 to the first power would just be negative 2. 5 squared is 25. So I'm going to end up with an answer 1 over negative 50 because I just multiplied these two together to get the negative 50. Okay, all right, I want you to go ahead now and try C and D on your own. So pause the video and push play when you've completed them. Okay, so let's walk you through here. On the first one, you've got negative 2 to the 0 power over 5 to the fourth. Okay, we just talked about this. Anything to the 0 power is 1, and technically I should have that in parentheses, so I'm taking the whole thing. So really I just have 1 over 5 to the fourth. And so 5 times 5 is 25, and then 25 times 25 would be 1 over 625. Okay. All right, and the next one here, I have 1 negative 2 times 5 to the negative 1. Okay. Now keep in mind there is an exponent on that 2, but it's a positive 1. So the only thing that's going to change sides is that negative 1, okay? Again, if you have a negative exponent, you've got to change sides. So I'm going to bring up the 5, and I'm going to get 5 to the positive 1, so I'm not going to worry about the parentheses, over negative 2 to the positive 1. Well, that's just really saying 5 over negative 2, and that's your answer. All right, and last problem here. A population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the W, where W is the number of weeks after the population was measured. Evaluate the expression for W equals negative 2, W equals 0, and W equals 1. What does each value of the expression represent in the situation? All right, so first thing we're going to do is we're going to plug in the negative 2. So I've got 5,400 times, what is that, 3? Yep, 3 to the negative 2. Okay, so now keep in mind that this negative 2 means it's going to drop to the bottom. So I really have 5,400 over 3 squared, because it would become positive, right? So over 9. So now when I take 54 and I divide it by 9, I get 6, and then just tack on the 3 zeros. So my first answer is 600. Okay, so now I'm going to do the same thing, except for I'm going to plug in 0. I believe that was the next one they said, right? Yep, 0 and then 1. So now I'm going to take 5,400 times 3 to the 0 power. Well, again, anything to the 0 power is 1, so this is like it doesn't exist, and your answer is going to be 5,400. Okay? And then on the next one, we've got 5,400 times 3 to the first. Well, 3 to the first is just 3, so 5,400 times 3 is, oops, I'm going to change color there, 16,200. Okay? All right, now let's think about what these mean. So if I'm looking at these exponents, okay, these are telling you, if you go back up here and read, it says where W is the number of weeks, kind of zoom out here real quick, W is the number of weeks after the population was measured, okay? So now, if I'm thinking about negative 2 here, negative 2 means that this would have been 2 weeks before they measured, okay? So there were 600 insects, 2 weeks before the first measurement. Yeah, almost. All right, so now if I do 0, well, then this would be the start measurement, the first measurement, the original measurement. So original measurement. Okay? And then if I'm looking at week 1 or 1, it's 1 week after the original measurement. Okay? All right. So that concludes 7-1 notes for today. Thanks.